Okay, so here we go with Chapter 18, Section 2, 18.2. We're taking a look at the idea of expected value and variance and therefore standard deviation. So the expected value, the variance of continuous probability models. So if you remember expected value from last section, that was where we made those probability distributions. And like we made that one for roulette. I think you would win $35 or lose $1, and this was 1 out of 38, and this was 37 out of 38. And we calculated the expected value, and we found that the expected value was about negative 0.05, or that you would lose 5 cents per play, per dollar. And basically what that was saying was, in the long run, if you played this game again and again and again and again and again, every once in a while you'd win, but most of the time you'd lose, and it would average out to be about 5 cents per play that you would lose. Well, we're going to do the same thing. We're going to calculate expected values, but we're going to calculate expected values for these continuous probability models. We're also going to talk about finding the standard deviation and maybe even calculating the median for a probability model. Okay? All right, so the expected value for a continuous probability model, the expected value of that continuous random variable, since calculating probability is based on calculus for these guys, then calculating an expected value is also going to be based on calculus, and it says that the expected value of a continuous random variable gives the expected average outcome for the random variable. The experiment repeated many times. It is also called the mean for the random variable. And we use this formula right here to find it. All right? So let's just blow that up and take a look at what it's saying to do. It's saying that the expected value, so this piece right here means expected value, is the same thing as the mean. And it's found by doing an integral from the lower limit, where the probability model is valid, to that upper limit where that probability model is valid. And then there's a slight change to the integrand here. See how they add this extra x? And so what that's doing is it's taking every value of the probability, every x, and multiplying it times its probability, and then integration is just a fancy summation where we just add them all up. So when we did this before for the discretes, it was x times p of x plus x times p of x plus x times p of x, where we added them all up. Same thing's happening here, it's just the adding up part is being done by calculus. All right? So let's take a look at an example and see how this plays out. All right, so here's our first example. And it reads, a recent study has shown that airline passengers arrive at the gate with the amount of time before their flight given by the probability density function f of t equals 3/4 times that mess for t valid between 0 and 2 inclusive. Okay, so basically what they're saying here is t represents time, represents the amount of time before the flight that a person will show up at the gate. And it looks like our model is valid from 0 to 2. That means that someone can show up between 0 minutes before their flight and, 0 hours before their flight and 2 hours before their flight. And that this model right here does the probability for us. Okay? So our job then is to find the expected value. Now my formula says that the expected value of a random variable x can be found by taking the integral from a to b of x times f of x dx. Now, the fact that this function is t's and this definition is x's shouldn't be an issue. It's just a switch of a variable, so let's not worry about that, but let's worry about the pieces and parts. I know that's going to be x. That is going to be that algebra right there. A is going to be 0 because that's the lower limit where that function is valid. B is going to be 2 because that's the upper limit where that function is valid. And then beyond that, it's just doing a bunch of math. Right? So let's plug some stuff in and make this work. Our expected value, e of x, is going to be the integral from 0 to 2 of x times 3/4 times 2x minus x squared dx. Okay? Now I'm going to do a little bit of manipulation of this expression so that I can rewrite this. It's going to be 3/4 times, there's going to be one integral from 0 to 2 of 2x squared minus x cubed dx. Right? So I factored out the constant, the coefficient, 3/4. I distributed the x times the 2x and times the x squared to give me that negative, or that 2x cubed and that 2x squared and that negative x cubed. Right? Haven't done the calculus yet, so let's go ahead and do the calculus. The calculus says that's going to be 3/4 that times the antiderivative of 2x squared is going to be 2/3 x cubed. The antiderivative of negative x cubed is going to be negative 1/4 x to the 4th, and I need to evaluate this from 0 to 2. I love when I have a limit of integration of 0, especially when it's a polynomial, because when I plug that 0 in, it's just going to become nothing. So all I have to do is just evaluate this thing at the upper limit. Okay? So that's going to give me 3/4 times 2/3 times 2 cubed minus 1/4 times 2 to the 4th. And let's see, what's that going to give me? Let's see, I got the 3/4 out in front. 2/3 cubed, I'm sorry, 2 cubed is 8. 8 times 2/3 is going to be 16/3. Minus 2 to the 4th is what? 2 times 2 is 4 times 2 is 8. 16. 16 over 4. Right? Which is going to give me 3/4 times 16/3 minus 4. And then if I distribute that 3/4 into there, I'm going to get 4 minus 3, which is 1. What does that mean? That the expected value is 1. Well, it means that when we run this experiment again and again and again and again and again, the average outcome is 1, or that on average, a passenger shows up 1 hour before their flight. Okay. Now, of course, I didn't have to do this integration by hand, because at this point right here, I have my integral set up. I could have put in the calculator. I could have gone and set up that integral in my calculator and said it's the integral from 0 to 2 of x times 0.75, that's 3/4, times 2x minus x squared, and those parentheses, that looks good, and this is dx. And I would get 1 doing it that way too. Okay. Now, if you're wondering why I did it by hand and didn't just use my calculator to begin with, it's because I like doing calculus by hand. I'm pretty good at it, and I enjoy doing it. So it wasn't that big of a deal to do it by hand for me. Okay. Either way, I get 1, but the bigger picture is, what does 1 mean? And so, do you see why 1 means this? Because we're talking about expected values. And what do expected values mean? Well, they mean that if you run the experiment, in this case the experiment is how long before your flight do you show up at the gate? If you run that experiment again and again and again and again and again, what's the average outcome? Some people are going to show up earlier, some people are going to show up later, but on average, when are people going to show up? And it looks like for this one, on average, they show up about an hour beforehand. Okay? Now, if we can find a mean, an average, we also want to be able to find a standard deviation. Remember, we want to talk about how are things spread out. Now, just like we're doing standard deviations by hand, technically, the process to find the standard deviation is you have to take your data and then turn that into the variance and then turn that into the standard deviation. Okay? And that process for turning data into a standard deviation is the same as the process for turning a continuous random variable. Remember, data would be discrete, but a continuous random variable into a standard deviation. The first thing we do is we find the variance, and the variance is found by this formula right here. And then we turn that variance into a standard deviation by taking a square root. Okay, so let's take a look at the formula. The formula says that the variance of a random variable x is found, remember that's just the symbol for the variance, by doing an integral from a to b, from that lower limit to that upper limit. And there's my probability model, f of x, and here's the extra bit that gives me my variance. Right? Now, if you remember from the time we did the standard deviation by hand, inside those parentheses right there, that x minus the mean, that's going to give us our deviation. That's going to give us how far a random variable value is from the mean, and then we square those because we did that, and then we would add them all up and divide by the, what's that word I'm looking for there? Oh yeah, divide by the number minus 1. Now this multiplying by the probability effectively does that dividing by. Okay? And so that's what's happening here. We're adding up the deviations and multiplying by a probability to come up with our variance. And then of course, how do you turn a variance into a standard deviation? Well, you unsquare it or you take its square root. Okay. All right, so what I would like to do is I would like to find the variance and the standard deviation for that previous example. Okay. Our previous example, if you remember, gave us a random variable x and a probability model of, I want to make sure I get it right, I believe it was 3/4 times 2x minus x squared, so it was 3/4 times the quantity 2x minus x squared. And we found already that the expected value, which is the mean, is exactly 1. And now I'm going to use that information right here. Oop, oop, don't want that. I'm going to use that information right here. And this formula, and I'm going to put those two things together, and I'm going to go ahead and find that variance and then the standard deviation. Okay? First things first, I'm going to find my variance. My variance for my random variable is going to be the integral from 0 to 2. Remember, this probability model, we were told that it's only valid between 0 and 2, of x minus the mean, but our mean is 1, squared, times our probability model, which is going to be 3/4 times 2x minus x squared dx. Okay? I'm going to do it by hand first, and then I'm going to go ahead and check it. Okay. Let's see, I'm going to take that 3/4, since it's a coefficient, and pull it out in front. Okay. So that's going to give me 3/4 times the integral from 0 to 2 of x squared minus 2x plus 1 times 2x minus x squared dx. Okay, now if you're wondering, I multiplied that out, and that's what gave me this right here. Now I'm going to just do a little more math. I got 3/4 times the integral from 0 to 2 of, let's see, I'm going to have a 2x cubed minus a 4x squared plus a 2x. Okay. Let's see, so I took all three of those and multiply that first term to get those three. Now I'll take all three of those and multiply them by the second term. And so that's going to give me a minus x to the 4th, a plus 2x cubed, and a minus x squared dx. Okay? Now clearly I did not give myself enough space here, but I'll just roll it and then erase it when we need it. So now I've got my 3/4 times my integral from 0 to 2. Let's see. I got a 2x cubed and a 2x cubed, so that's going to give me 2x to the 6th. I got a negative x to the 4th. That's there. Looks like I got a negative 5x squared. And I've got a positive 2x dx. All right, now I'll integrate. When I integrate, that's going to give me 3/4 times 2x to the 6th would be 2/7 x to the 7th minus 1/5 x to the 5th. Wait a second. Okay, dummy. That's a cubed because 2x cubed plus 2x cubed is 4x cubed. So I don't know what the heck I was thinking there. My brain was somewhere else. And so that's going to give me just plain old x to the 4th when I integrate. Okay, so that one's done, that one's done. Negative 5x squared is going to give me negative 5/3 x cubed. 2x will give me x squared. And again, this is from 0 to 2. I love the fact that it's a 0 because here, 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 and here is just going to go away. So all I have to do is evaluate it 2. So that's going to give me then 3/4 times x to the 4th 2. 2 to the 4th is 16 minus 32/5. X to the 5th is 32 times 1/5, 32/5. X cubed, when x is 2, is going to give me 8. So I've got negative 40/3. X squared is going to give me a positive 4. That's going to give me 3/4. The 16 and the 4 is 20. Minus 32/5 minus 40/3. I'll distribute that 3/4 into there. 3/4 times 20, 20 divided by 4 is 5, that's going to be 15. 3/4 times negative 32/5, the 4 and the 32 are going to give me a negative 8, so I'm going to get a negative 24/5. 3/4 times negative 40/3 is what? 10, negative 10? Oops, I don't need that. 15 less 10 is 5. So I've got 25/5 minus 1/5, 24/5, sorry, and that's going to give me 1/5. And what did I just find? Oh, I found my variance. So my variance of x is 1/5, and so that means that my standard deviation is going to be the square root of 1/5, or if you think back to your college algebra, when we rationalize, we would get root 5 over 5. So my standard deviation is root 5 over 5. Now I have zero faith in myself because that was a lot of math, and I know I made at least one mistake, and I'm hoping I didn't make more. So I'm going to go back up here, and I'm going to say, okay, the easy way to do it, we just to take this right here and just put that directly into the calculator. So I'm going to go back and try that. Let's see. I need to do an integration. Lower limit is 0, upper limit is 2. My integrand is going to be the quantity x minus 1, that quantity squared, times 3/4 is 0.75, times 2x minus x squared, close those parentheses, and I'm doing this with respect to x. And I get 0.2, 0.2, 0.2, math, enter, enter, 1/5. And that was exactly what we got by hand down here. We got the 1/5. And then we're going to take the square root of that. Now, if I take the square root of that 1/5, it's not going to give me root 5 over 5. It's going to give me the decimal equivalent. Right. So what that's saying there is that the, I don't want that one. It's saying that the standard deviation, which is equal to the root of 5 divided by 5, is approximately 0.447, round wherever they would tell me to round it to make that thing work. Okay. So what I'm looking at there is I'm just looking at the standard deviation of this distribution. Now I'm going to put this away, and I'm going to go back up here and try to figure out what the heck I just figured out. What did I just figure out? Oh, I know what I did. Okay, I found out that the average time that someone shows up at the gate was 1 hour, with a standard deviation of about 0.4, what was it, 4.45 if we round it to 2 decimal places, hours. So it looks like while the mean is 1, there's quite a bit of variability there. And I don't know about you, but my experience at the airport is pretty much the same. That there's a lot of variability between when people show up at the gate. Right? All right, so let's go ahead and take a look at the next question here. So I'm going to have to erase a bunch of this. In fact, I'm going to have to erase everything from here on down to make this work. Let's see how much of this I can get with my eraser here. I think I got most of it. Yeah. Okay. This question says that, what is the probability that a passenger arrives at the gate between 1 standard deviation below the mean and 1 above? Okay, so I know to calculate probability, I know that I'm going to do an integral because I have a continuous random variable, and this business right here is going to tell me my limits. I know that the probability for some range of a random variable is just going to be an integral from that a to b of that probability density function. So I just need to do this. I need to figure out what my function is. I need to figure out what my lower limit and what my upper limit are. Right? Now this says between 1 standard deviation below and 1 above. So that tells me that A is going to be the mean minus a standard deviation, which in this case is going to be 1 minus 0.45, which is 0.55? And B is going to be 1 standard deviation above the mean, so that's going to be 1 plus 0.45, or 1.45. And I know my function. My function has been given to me a couple of times. It's 3/4 times 2x minus x squared. And it looks like I should be able to calculate this. So I need to do the following. The probability that 0.55 is less than x is less than 1.45 is equal to the integral from 0.55 to 1.45 of 3/4 times 2x minus x squared dx. So I'm going to go grab my calculator. I'm going to do a integral. My lower limit is going to be 0.55. My upper limit is 1.45. And my function was 3/4, so 0.75 times the quantity 2x minus x squared. Do this with respect to x, and I get that this is approximately 0.63, or there is a 63% chance that someone will show up at the gate between 1 standard deviation below the mean and 1 standard deviation above the mean, or between half an hour before to 1.5 hours before their flight takes off. That wasn't too bad. All right, we're at 23 minutes. That was a really long video, but that was the entire section 18.2 right there. So I'm just going to stop this right here, and we'll come back. The next video you'll see will be section 18.3. Have a good one.